Hi everyone, this is Scott Reeves, and this is Lipid Lecture 3 of FSN 328. And this is going to be on two different topics. And the first one is atherosclerosis, and that's what we're going to go through first. And then the second part of this lecture has to do with how the diet affects lipoprotein metabolism. So the first part on atherosclerosis is part of your worksheet for extra credit. And then the rest of the material on dietary effects on lipoprotein metabolism is for your own information for exams and potentially a quiz, but it's not part of the extra credit. And so let's go ahead and get started. Let's look at the prevalence of atherosclerosis. I think we hopefully all realize that it is the #1 lethal disease in most developing countries, including the U.S. So heart disease is a very common ailment here in this country especially. And when we talk about heart disease and atherosclerosis, let's just give a brief description of atherosclerosis. It is essentially the accumulation of cholesterol and lipids in arteries, and then it narrows the arteries and can cause a blockage, which causes oxygen delivery to be stopped, and that can cause death of tissue in the area that's no longer exposed to oxygen, and that's what can lead to a heart attack, also known as a myocardial infarction. So it is also sometimes referred to as hardening of the arteries. And as we go through this process and I explain the steps in this, you'll see kind of why it's described in both of those ways. What are some of the risk factors? Well, in lots of health scenarios, genetics is a major factor, so that is part of it. And I think an important thing to keep in mind here is that, remember, this is multifactorial. And just because a person has kind of less than optimal levels of any of these, it doesn't mean that a person's going to get heart disease. It just means that they might have one of the risk factors. Another thing that increases risk of heart disease is being male, and one of the reasons is because women tend to have high density lipoprotein cholesterol. So women tend to have higher HDL-cholesterol, and that's a protective effect. So women can live longer. We know they do, and this is one of the reasons that they potentially do, is because of their lipoprotein profile and decreased risk of heart disease. Another major factor is cigarette smoking. It is the main cause of atherosclerosis and death in about 20% of those individuals. So it is a very potent effector, an initiator of heart disease. So that needs to be considered as far as a person's health profile. So the cigarette smoking, one of the reasons it causes increased risk, especially to death from cardiovascular disease, is smoking potentiates clotting in the blood, and so it can increase the risk of atherosclerosis and stroke. Another thing that is a significant effector is high blood pressure. That can lead to some of these steps that we'll talk about. And obesity is a risk factor, especially if there is excess adipose tissue around the abdominal area, and that is can be a major contributor in this process. One of the reasons is, as a person accumulates more body fat, they tend to develop more insulin resistance, and so that can lead to an increased blood cholesterol levels, but also blood glucose levels, and that glucose can bind to LDL molecules, and those LDL molecules, if they are bound to glucose, have a higher likelihood of being involved in the atherosclerosis process. So the insulin resistance can be a big part of the obesity in this case, and also sedentary lifestyle. And that sedentary lifestyle does a few things. It increases the likelihood of obesity. It also increases the likelihood of insulin resistance occurring, and so that can be a factor. And also, exercise can help us maintain a healthy lipoprotein profile. In other words, higher HDL levels, for example. So those are some of the overall risk factors. If we look more specifically at what some of the biochemical risk factors are, a high plasma or blood LDL cholesterol increases risk. Low plasma HDL cholesterol increases risk. High plasma triglycerides does, and a lot of times you see high blood triglycerides with obesity and insulin resistance. That's why they're kind of linked. And then diabetes is the last one. If a person has diabetes, it doesn't mean they're going to get cardiovascular disease, but it does mean that they have increased risk of that, especially and mostly for those that do not or cannot consistently regulate blood glucose levels. Okay, so let's look at this process. Now, I also posted on our website an article that was written a few years ago by an individual named Peter Libby. He has been in this for a long time, and he wrote an article that I really liked. I haven't found a better one yet, in a journal called Scientific American. So it's basically an expert like Dr. Libby writing a description of atherosclerosis in layman's terms. So it's something that you can refer to as part of this extra credit assignment in case you would like more detail on this process. So that is posted up there as well. That's called Atherosclerosis, the New View. And the view of this changed years ago when they realized that atherosclerosis isn't caused by cholesterol just sitting on the walls of an artery. They realized that the process involved accumulation of lipids underneath the surface of the wall of the arteries, especially in the arteries of the heart. So this involves some of the blood vessels within the within around the heart itself. And it is, when it says the response to injury, it means that cells within the coronary artery are injured. And the causes of the injury, most common causes of injury, include hyperlipidemia, which is obviously high blood lipids. That's mostly high cholesterol, but it can also be associated with high triglycerides. So that's one potential cause of injury. A second one is smoking, and that's cigarette smoking. And it can be a significant cause in the injury. And then hypertension, high blood pressure. Everyone should know their blood pressure levels. And so otherwise it can be relatively asymptomatic, but it can be contributing to risk over a person's lifetime, and they might not even know it. So in this process, the main players are cells of the immune system and lipid material. And that's most commonly, that lipid material is LDL cholesterol and LDL particles. So we're going to look at how this process plays out, and I'm going to put it into 5 different steps. And I want you to describe each of these steps in just probably something like 2 to 4 sentences, and then we'll get an idea how one step leads to the next. And I think that would be my suggestion on how to remember this information, is just remember enough details so you can explain how one part of the process leads to the subsequent step, and eventually how that leads to cardiovascular disease. So let's look at step 1. So I'll go back and forth here. So this is step 1, where the coronary artery is actually injured. And this diagram, this artwork is taken out of the article that I posted up there in case you want to look at that. But hopefully you can see the cursor in this case. Here we have, for example, we're looking at a coronary artery in closer detail. And we can see the physical structure of the artery shown here. The opening of the artery is called the blood channel, or the lumen of the artery. The next layer going towards the outside is called the well, actually there is a layer of endothelial cells. We'll look at that in a second. And those endothelial cells, for example, if we look at this area in detail, you can see where it says endothelial cells. Endothelial cells are a cell type that makes the walls of blood vessels. Be careful, these are not epithelial cells, these are endothelial cells. And you can see there's a single layer of them. Okay? underneath the endothelial cells are what's called the underlying tissue of the intima. So the intima is composed of an outer layer of endothelial cells and then connective tissue through here. Okay. Then we have the media, which is shown down here. We have connective tissue, and then down here we have smooth muscle cells. And then on the outside part of the blood vessels, we have what's called the adventitia. We're mostly going to be talking about the intima and the media in almost all of this. Okay. So in step 1, there is an injury to the endothelial cells and or the underlying connective tissue. Okay. Now, there are 3 main causes of injury. I mentioned these. One is hyperlipidemia, one is smoking, and one is high blood pressure. Okay. Now, when these conditions cause an injury, the injury promotes the release of chemokines that attract monocytes. So chemokines are small signaling proteins, and they are released by, in this case, the endothelial cells. So let's say these endothelial cells were exposed to high blood cholesterol levels in LDL, or smoking, or high blood pressure, and they basically sustain an injury. The endothelial cells respond by releasing chemokines. Chemokines are those small little protein signaling molecules. Okay? So that's one of the things that they do. Those chemokines attract monocytes. So monocytes are kind of traveling through the blood. Monocytes are undifferentiated macrophage. So monocytes are cells of the immune system. Chemokines also attract T cells. Now, basically what's happening is the immune system is responding to an injured tissue, and the immune system can interpret that as a harmful molecule, or invaders have basically gotten into a system, and the immune system is targeting that to try to stop this from spreading. The other thing that injury does is when these endothelial cells are injured, they increase expression of a protein called adhesion molecule. So this is all in step 1. Right, we have the injury that occurs. The injury is from the 3 things that I mentioned. The injury promotes the release of chemokines that attract monocytes. The injury also increases expression of adhesion molecule. Okay? So that's what has happened so far, and I'll go back through that a little bit. Step number 2 is called macrophage accumulation. The monocytes that are responding to the injured area bind to adhesion molecules, and the monocytes can kind of roll in between the endothelial cells and get into the underlying intima. T cells can do the same thing. The monocytes can pass between the endothelial cells and interact with the molecules in the intima, including the LDL that has now gone from the blood into the underlying tissue. Now LDL, that's a normal occurrence. The LDL can leave the blood, and they can leave the blood so that they can deliver cholesterol to underlying tissues. The problem is if there's too much LDL cholesterol, then that increases the likelihood that the macrophage are going to encounter the LDL and engulf it. Okay? As the monocytes moved through the intima, the chemokines convert the monocytes to macrophage. The macrophage then engulf the LDL particles using an unregulated pathway known as the scavenger receptor pathway. Because it's unregulated, the macrophage continue to accumulate excessive lipids. So no matter how much lipid this macrophage accumulates, it'll keep finding these LDL, consuming the LDL until the macrophage becomes this huge cell here. And it's hard to see. Well, you can see it a little bit right here, but these macrophages are expressing these LDL receptors so that the LDL are binding to the receptor, and then the macrophage is engulfing that LDL particle. It's taking in, at this point, excessive amounts of cholesterol, and that's causing the macrophage to become necrotic or dysfunctional. Okay? Normally what a cell can do is it can take up a certain amount of LDL cholesterol and then downregulate this process. But this is an unregulated process that macrophages are doing, and in a way they're kind of sacrificing themselves in order to try to take up that LDL. So here's an important point. The macrophages tend to target modified LDL. In other words, damaged LDL particles. And there's two main types of damage or modifications that we're going to mention here. And one is glycation. And that means that carbohydrate, more specifically glucose, has bound to the LDL molecules. The second modification tends to be oxidation of LDL. So if an LDL molecule is traveling through the blood, or as it moves through the intima, if the LDL lipids are oxidized or the LDL protein is oxidized, the macrophages tend to target those molecules. So in other words, if a person is smoking and they have more oxidized LDL, the macrophage tend to look for those LDL. If a person has chronically high blood glucose and it's bound to LDL, the macrophage actually target those LDL as part of this process. So that's why those are increased risk for this process occurring. Okay, so that's step number 2. We're down to macrophage accumulation of LDL particles. Step number 3 up here, fatty streak formation. So now you can imagine as significant molecules, macrophage have picked up LDL molecules and they're starting to accumulate it. These macrophages become dysfunctional macrophages. In other words, they're no longer able to perform an immune function. And they start accumulating so much LDL that they are essentially converted to foam cells. So the accumulation of lipids by macrophage causes them to become foam cells. When enough of these foam cells are made, it forms what's called a fatty streak. It is a visible bulge of the intimal layer caused by foam cell accumulation. Oops. So that's what's happening here. We have fatty streak formation where we have this tissue that is now becoming necrotic because so many cells, including T cells and foam cells and some macrophages, are starting to accumulate in this area, that now we're starting to get a damaged tissue. Okay, so let's look at the next one. And this is a nice little diagram showing what normally is happening in the blood. We have some monocytes and some T cells and a lot of red blood cells that are essentially moving through the blood. And then we have steps 1, 2, and 3 kind of shown there. Well, you can see here, this tissue is now accumulating enough molecules and lipids where it's starting to bulge into the opening or the blood channel and is starting to close off blood flow. So that's what can happen sometimes. So remember, this process is occurring within the arterial wall, not on the outside of it. So let's look at step 4. This is called plaque progression. This is when smooth muscle cells migrate to the top of the fatty core or streak. Okay? These molecules, the macrophage and the T cells within this fatty streak, release chemokines that cause the smooth muscle cells to migrate to the top. So you don't have to write this down, but what's happening is the tissue is trying to close the streak off to keep this blood vessel wall from rupturing. So smooth muscle cells move to the top of the streak. When those smooth muscle cells migrate to the top, they begin synthesizing and releasing collagen. And that's a fibrous protein that is part of the plaque. Collagen is a protein that binds cells together. So the smooth muscle cells that have moved release collagen that causes this to become a fibrous cap to the fatty streak. The process can repeat until this blood vessel is closed off. So plaque progression can continue until there is occlusion or blockage of the coronary artery, and that can cause a heart attack. That's normally not what happens. That only occurs in about 15% of the time. 85% of the time, there's what's called a plaque rupture. Okay? Now, we can see kind of the same scenario here. We have these cells that are embedded in this fatty streak. They're releasing chemokines and cytokines that are affecting the other tissues. Now, some of the cells in this clot release collagenase. Collagenase is the enzyme that breaks down collagen. That can cause the plaque to rupture. So if these cells are releasing collagenase, the collagenase breaks down the connections between the muscle cells, and now there is exposure of the underlying cells to blood flow. So when the blood, more specifically, when platelets of the blood are exposed to tissue factor on these cells, that stimulates clot formation. And a clot can also be referred to as a thrombus, Thrombus. And that can cause a clot to block the artery. So here's a good diagram showing that. So remember, now what's happened is we have a rupture in this cap. Platelets that are traveling by, platelets are blood clotting cells. They will bind to tissue factor in this tissue. The platelets are activated. That stimulates a clotting cascade. The clot or thrombus can now block this artery. So this area of tissue within the heart is now devoid of blood flow, and that can cause a heart attack. Okay? What can happen sometimes, though, is that clot, rather than staying localized, can travel through the blood. So pieces of this clot can break off, travel through the blood, where they can lodge in another place and block blood flow. For example, if that happens in the brain, that's a stroke. So sometimes stroke starts in another part of the body, and that clot can actually travel. Anytime a person is injured significantly, any kind of physical trauma, one of the concerns is a blood clot, and those blood clots can move. If it goes into the kidney, it can cause embolism, it can cause lots of different problems. But if it does occur in that local area or in another part of the heart, then that can cause a heart attack as well. So that is the more likely possibility that a blood clot is going to affect this. So now when you think about some of the things that are going on here, we have the injury risk from various components that I mentioned, but the immune system is part of this. So inflammation or chronic inflammation potentiates this process. We talked about omega-3s and omega-6s, so now you can kind of get an idea, oh, if we have kind of an upregulation or chronic stimulation of the immune system, that perpetuates or enhances this process. Obviously, that's not a good scenario. So we want to make sure that we're consuming foods in our diet that don't lead to perpetuation of this process. And even things like clotting are a problem. I said one of the protective effects of omega-3s are it decreases blood clotting. Well, now you can kind of see how that might be related to this cardiovascular disease and the risk of stroke. So you should have like about something like 2 or 4 or 5 details from each of these, and we need to go back through this, and you can fill out the worksheet that you have for this now. Okay, so now let's look at how diet is involved in this, because in a lot of ways this is the process where diet and diet and cardiovascular disease, this is where the two kind of combine, or where the rubber meets the road. So this is diet, lipoproteins, and the risk of cardiovascular disease. So for a long time, the therapy has been based on the goals of reducing the concentration of LDL cholesterol and increasing that of HDL cholesterol in the plasma, right? In general, the more LDL cholesterol you have in the blood, the more likely it can be involved in that atherosclerosis process. The more HDL you have, that HDL is moving cholesterol away from tissues to the liver for excretion. So that's why it's protective. And so the reduction of LDL cholesterol is expected to limit the uptake of cholesterol by cells within the fatty streaks. So it is important to keep that in mind. And it's been estimated that for every 10% increase in LDL cholesterol in the blood, there's a 20 to 30% increase in cardiovascular disease risk. Oops, so let's go to this one. Okay, and I was just reading here. Now, the role of dietary cholesterol and dietary fats. They can affect cardiovascular development by modulating plasma lipoprotein concentrations like LDL and HDL. So dietary modification should remain the cornerstone of cardiovascular disease prevention. Rather than trying drug therapies, people should try to address it with diet and lifestyle changes first. And this is the thing I went through. It's estimated that every 10% increase in LDL increases the risk of cardiovascular disease by 20 to 30%. So the amount of dietary cholesterol a person consumes is important. The amounts and types of fat that a person consumes is also important in this process, because it can affect lipoprotein levels of LDL and HDL. Now, the average U.S. diet contains approximately 34 to 38% of calories from fats. And a better number would probably be, we should probably consume maybe 25 to 30% of our dietary calories from fats. Now, that is a general statement. If a person increases their fat intake for whatever reason, we want to make sure that it is the good type of fat. And that's one of the reasons that we're talking about this. But overall, both the amount and type of fat affects plasma lipoproteins. And if you want to do the math on this, you can kind of maybe guess how many calories you eat per day, and then say, well, let's say 30% of my calories from fat. And then start multiplying that out by the number of grams of fat that a person consumes each day on that diet. And then how many grams of fat that is a week, every month, and then multiply it out by a year. And you would see that, a lot of people eat between like 50 and 70 pounds of fat a year. Now, what if a person stays on the same diet for 5 years or 10 years or 20 years? Think of all that fat essentially moving through your tissues and affecting downstream processes, including atherosclerosis. So I know that right now there's some high-fat diets that people are saying, are doing them wonders, and they should become more popular. We want to be careful about following, suggestions by individuals that are not assessment-based. We want to always make sure that we're using data and evidence to drive our recommendations for people. So one of the ways to assess that is the effects on lipoprotein profiles in people. So let's start with saturated fatty acids. Now, in general, lots of evidence has shown saturated fatty acids tend to increase plasma LDL cholesterol. In general. And the average U.S. saturated fatty acid intake is approximately 12% of energy, and it should be probably less than that. For example, palmitic acid, we know is the C16-0, is the major saturated fatty acid in most diets. For example, it's more common than stearic acid, which is more common than myristic and lauric acids. And unfortunately, palmitic and myristic fatty acids tend to have the greatest LDL cholesterol raising potential. Two that are most common, unfortunately, appear to be two of the more harmful. And here's how saturated fatty acids can affect LDL cholesterol. Saturated fatty acids tend to decrease LDL receptor mediated endocytosis by decreasing LDL receptor levels at the plasma membrane. And in general, the more LDL receptors that a person has on their tissues, the less LDL cholesterol that stays in the blood and participates in atherosclerosis. So that's why there's concern with saturated fat intake. And the saturated fatty acids can do this. It's hypothesized by two different ways. One is saturated fats tend to decrease LDL receptor gene expression. So we end up with less expression, less translation, and less receptors on the cell surface. The second thing that's believed is if saturated fatty acids are coming in from the diet and then becoming part of phospholipids that are in our cell membranes, it's thought that those saturated fatty acids in the plasma membranes might decrease LDL receptor recycling. And we'll learn why that's important, but in the end, that can decrease LDL receptors as well. Okay, so in general, that's what saturated fatty acids can do. One of the exceptions is stearic acid. And remember, stearic can be converted to oleic, so stearic is a different fatty acid than the other ones because it can be converted so it does not increase LDL cholesterol. Okay, let's look at trans fatty acids. And what I would do is maybe make a table of these. So let's say saturated fats, trans fatty acids. You might want to, mention where they come in from the diet, what are the most common fatty acids from each of these different categories, and then what are their effects on lipoproteins. Right? So we're saying, for example, saturated fatty acids, including palmitic and myristic, increase LDL cholesterol. Trans fatty acids, the major one in our diet, tends to be Elaidic acid. We know that that's a C18-1. It's a trans fatty acid. And remember, some of them occur naturally. They can be in some animal products. Some of them are from food processing. And that's mostly because of partial hydrogenation of oils. And then overall, though, about 6% of our dietary fatty acids are trans fatty acids. Now, these numbers are from a few years ago, but and I think it's gone down a little bit, but there still can be considerable amounts of trans fatty acids in our diet. And as far as this information goes, please use this lecture when we're on an exam or quiz or anything when I ask you about the effects of different types of dietary fats on lipoproteins. So go by my information rather than the textbook, because I've used some different sources that I trust, so use my information on this. Okay, so overall, most studies show that trans fatty acids increase LDL cholesterol. And that's one of the reasons trans fatty acids are thought to be unhealthy. Some studies have also shown that they decrease HDL cholesterol. Okay? So that would be the worst scenario, right? Increasing LDL cholesterol and decreasing HDL cholesterol. Okay? It says some studies because not all studies have shown that trans fatty acids decrease HDL cholesterol, but there is that potential, so they might. And even though we're not exactly sure how much of it you have to have in order to decrease HDL cholesterol, so the effects are still kind of controversial, no one's claiming you should eat a lot of trans fatty acids. So reducing their amounts is unanimous. Most people will say trans fatty acids are not good for us. Okay? Dietary monounsaturated fatty acids. So many studies have shown that when substituted for saturated fatty acids, monos reduce blood cholesterol. Okay? However, the complete picture of their effects is still a little bit controversial. For example, monounsaturated fatty acids tend to decrease LDL cholesterol. That's pretty straightforward. I think we can say that. The effect on HDL cholesterol is a little bit less clear. In other words, the ideal scenario would be, well, monos decrease LDL and increase HDL. I don't think we can say that. Okay? They may have a positive effect on HDL cholesterol, they may not. But overall, they do have a positive effect on LDL cholesterol. In other words, they decrease it. Now, overall, in general, it appears that monounsaturated fatty acids do not decrease LDL cholesterol as much as polyunsaturated fatty acids. Okay? So they can decrease LDL cholesterol, but not as much as polyunsaturated fatty acids. And in general, two of the better sources tend to be olive oil, canola oils, tend to be fairly common sources of monounsaturated fatty acids. So the Mediterranean diet and other diet plans that include a lot of olive oil, that's one of the important health benefits is their effect on LDL cholesterol. And here's one of the reasons. Oleic acid, for example, has been shown to increase expression of the LDL receptor, and that decreases LDL cholesterol in the blood. So oleic acid, as it's going into cells, can affect the expression of the LDL receptor. It increases it. The more LDL receptors you have on cells, the more LDL cholesterol is taken out of the blood and into cells where it does not have a harmful effect. Okay? Now, olive oil, we know, we looked at this before, it contains about 75% of its fatty acids is oleic acid. So that's one of the reasons olive oil is so good. 75% of its fat is oleic acid. Let's look at polys. So polyunsaturated fatty acids can decrease LDL cholesterol. That's accepted. For example, linoleic acid. We know that is one of the essential fatty acids. Even though it's an omega-6, it can decrease LDL cholesterol. And so that's one of the reasons in this case consuming this one, even though it's an omega-6, can be helpful. Now, here's the issue. Linoleic acid reduces both LDL and HDL cholesterol. So we say it is best to consume lipids that come from, or fatty acids that come from saturated, monounsaturated, and poly. If we ate too much polyunsaturated fatty acids, it might actually decrease our HDL cholesterol and kind of remove that protective effect of HDL cholesterol. So again, each of these different types of fatty acids in moderation. I think you could argue that consuming less saturated than unsaturated is overall good. But in general, we say if a person has, let's say, 25% of their calories are coming from fat, we probably want approximately a third coming from saturated, mono, and poly to make up that total fat intake. Okay? So dietary polyunsaturated fatty acids can have a beneficial effect on LDL cholesterol. Okay? Now, so polyunsaturated fatty acids are beneficial because of their effects on lipoprotein metabolism. Omega-3 fatty acids, which we've talked about, are polyunsaturated fatty acids. For example, omega or N3s are high in fish oils. They lower blood triglycerides and reduce the risk of cardiovascular disease. So they tend to reduce triglycerides in the blood. They have beneficial effects on lipoproteins, but some of their effects are independent of their effects on plasma lipoproteins. In other words, remember, omega-3 fatty acids reduce clotting. They reduce blood pressure. They reduce inflammation. They protect against irregular heartbeat. So omega-3s not only have a beneficial effect on lipoproteins, they work through eicosanoids as well. So that's another reason omega-3 fatty acids are such an important part of a healthy diet. Okay. What about dietary cholesterol? A lot of studies have shown dietary cholesterol to have less potent effects than saturated fatty acids. So this is again why I say to be careful when all these people are saying, hey, eat a bunch of fat. Saturated fat doesn't hurt us. It's controversial right now, and we need to be careful about how we advise people, but a lot of studies have shown saturated fat intake can be more harmful than actual dietary cholesterol. Okay? Dietary cholesterol is more variable in its response to dietary fats. In other words, some people do really need to watch their cholesterol intake. Others really do not. For example, I have a grandfather, he ate 3 or 4 eggs every morning for all of his life, and he had low blood cholesterol. Okay? But not for everybody. And here's another thing to keep in mind. But dietary fats and cholesterol tend to interact. Okay? In other words, a worst case scenario could be high dietary cholesterol and high saturated fat intake. Best scenario tends to be monitor or watch cholesterol intake and saturated fatty acid intake. For example, saturated fatty acids reduced to 7% or less of energy and cholesterol reduced to less than 200 milligrams per day can result in plasma cholesterol being reduced by 15 to 20%. And remember, that reduction in cholesterol can have a significant decrease in the incidence or risk of cardiovascular disease. So controlling both of those for a lot of people is the most effective way to go about this and helping to control at least some of the risk factors for heart disease. And remember, the magic number that we used to look for cholesterol was 300 milligrams a day. And now that's not really a specific recommendation anymore. But I still don't think we should just say, eat whatever cholesterol you want. It's important that a person knows their blood cholesterol profile as far as LDL, HDL in total before they think diet is not affecting it, because it might be. Now, one of the great things would be, well, why don't we just raise HDL? What can we do to do that? Well, it's not a piece of cake. It's not that easy to increase a person's HDL cholesterol. There are a few things, though, that in general can really help. For example, physical activity tends to raise HDL. For example, one study showed a 45-minute activity 4 times a week can raise it by about 5 milligrams per deciliter. Now, that might not sound like much, 5 milligrams, but when you're talking about, for example, in men, a value that might be average for even college students might be 45 or 50 milligrams per deciliter. So that's a 10% change, and that can have a positive effect. Now, one of the questions is what type of exercise? It's really variable, but in general, it should be vigorous, and you need to burn quite a few calories. That seems to be what tends to have the better effects. But when you read study after study, you can see there's quite a bit of variability on which type of exercise are required to have these effects. Another thing that can raise HDL cholesterol is weight loss, especially when it's around the waist. In other words, abdominal fat tissue tends to suppress HDL cholesterol. Okay? Moderate consumption of alcohol. I should probably underline moderate. Consumption of alcohol has also been shown to raise HDL cholesterol. This is one of the effects where we say, hey, a glass of wine a day is actually healthy. Let me put it this way. It probably doesn't hurt many people, but the effects are not so significant that we say you should start drinking. Okay? So it can be helpful, and this is alcohol. It's not just wine. It's not just red wine. Red wine has ethanol, and it also has polyphenols that can be protective. So red wine kind of has an additional benefit as compared to just ethanol. But even a drink of a regular drink that's not red wine can be helpful, and as far as affecting HDL. It doesn't do it in everybody, but in some people it does. So that's one of the reasons you hear some about that, is its effect on HDL cholesterol. I think I've gone through everything that I need to, so hopefully that's clear. If it's not, you can go back through and take your notes. So I'm going to stop this lecture here.